All right, with this lesson we're going to be looking at solving equations with variables on both sides. However, our key difference with this video is dealing with different solution types. All right, so when we solve an equation, for example, like number 11, we have three different outcomes. All right, one outcome, we'll write it over, well, let's write it up here. One outcome is that you will have one definite solution, meaning that when you're done solving the equation, you'll get something like, say, x equals a number, whatever that number is, whether it's 3, a million, -2, whatever, it doesn't matter. You'll get your variable equals a number. So that's one option. And so far, maybe that's all you've seen. All right. Well, there are two other options. Okay. Now, these two options can be found two ways. All right. The first option is what we call a no-solution scenario. Okay. Meaning that you end up with something like this. The variable ultimately will cancel out. So you'll get something absurd, something that'll look like this. Say 2 equals 4. All right, well, it's very obvious that 2 does not equal 4. So when you're done with your work, the variable will disappear, and you'll have a constant on one side, a constant on the other, and they don't end up being equal. So when that happens, we simply write no solution as our answer. Now, you should, in your work, be able to see it long before this point that something's wrong. So, for example, it might look like this. It might look like 3x plus 1 equals, say, 3x plus 5. Now, that doesn't look a lot different than what we've been doing, but notice what's going on. Coefficients are exactly the same. I've got a 3 with my x here and a 3 with my x there. So these two numbers, whatever they are, this 3x, they're the same. But notice over here I'm only adding 1. Over here I'm adding 5, and supposedly that makes them equal. Well, think about it. If you have a sibling, let's say you get 3 of something, and they get 3 of something, and then your mom says, well, fine, let me give you 1 more, but then turns to your sibling and says, well, let me give you 5 more, you clearly can't be equal. All right? So if you work this out, notice 3x minus 3x is 0, you're left with 1 equals 5, and 1 can't equal 5. So that's your other option. So you have one solution, no solution, and then your last option is infinitely many solutions, or sometimes written as all real numbers, meaning that any number will work. And again, you'll notice that, or know that this happens two ways. The first option is very similar to no solution. You'll end up canceling out your variable, x or m or whatever you're using will disappear, and you'll get something that's obviously true. So for example, you might get something like 2 equals 2. Well, 2 is obviously always going to equal 2, so in that case you would simply write infinitely many solutions or all real numbers, meaning that any number could be plugged in and worked. Now, you should recognize this situation occurring long before you get here, and it could look something like this. And we'll use something similar as what we did up here. You'll get something like 3x plus 1 equals 3x plus 1. Well, notice both sides are exactly the same. We've got the same coefficient, we've got the same constant on both sides. So no matter what I put in for x, it's always going to equal out. So if I put a 2 in on both sides, well, notice what happens. 2 times 3 is 6. Okay, over here, 2 times 3 is 6, plus 1 is 7, plus 1 is still 7. They equal. So it doesn't matter what number I plug in here, it's always going to work. If I try 100, 3 times 100, 300. 3 times 100, 300. Plus 1, 301. Plus 1, 301. So we've got these three different possibilities now. You could end up with x equaling a number, okay, your variable equaling some value. You could end up with something that's obviously not true, like 2 equals 4, or same coefficient, different constant, meaning there's no solution. Or infinitely many solutions, all real numbers, where you get an obviously true statement, like 2 equaling 2, or same coefficient, same constant, same coefficient, and same constant. So let's look at some examples here so that you can kind of see how they play out. Let's try number 11. Number 11 isn't necessarily a difficult problem, but notice I have picked a multiple choice format just because you will see that on quizzes and tests. You might as well practice. So what I want you to notice right off the bat is that since this is a multiple choice problem, notice it doesn't give us the option for either no solution or infinitely many. So this will clearly have one solution. Let's look over here. In this case, no solution is an option. So this could look a lot like this scenario. All right? So when you're taking a quiz or a test, if it's multiple choice, you should have some idea of what the possibilities are based on the answers provided. Let's look at 14 real quick. Well, notice you have two potential one solution scenarios, Could be all real numbers, okay, infinitely many, or no solution, meaning that you're going to get something absurd. So if you're dealing with a multiple choice format, it'll be a little easier. Now, if you're dealing with something where you don't have choices, well, then you're just going to have to be vigilant. If you ultimately work it out to something like this, well, then you know there's one solution. Or if it starts looking like either of these, well, again, you'll know what's going on. So let's try number 11, work through it so you can see how it is truly a one-solution scenario. First thing we're going to do is we're going to multiply this negative 5 through. So negative 5 times 6, and I'll do my work down here. We'll get a negative 30m. Negative 5, notice that is a negative 7. So negative 5 times negative 7 is a positive 35. Equals negative 31 minus 8m. And I want you to notice something here. This is how I know for certain that there's only one solution. My coefficients are different. Notice I've got a negative 30m on this side, and that's the only term with a variable. I've got a negative 8 on this side. Notice the only term with a variable. Meaning there's going to be one solution. They're different. So we can start working this out. Now in this case, what I would do is I'm going to move my m's to the right-hand side. That way I'm adding 30. And when I do that, we'll get a positive value over here. So these cancel out. We're left with, let's put a line here. We're left with 35 equals negative 31 plus, let's see here. We got a negative 8, a positive 30, so that would be a positive 22m. All right. Next, we'll go ahead and add this 31 to both sides to get rid of it. We'll get 66 equals, that zeroes out, and we get 22m. Now it's just a matter of division. M is equal to 3. So in this case, we're wanting choice D. So notice, one solution. We had a variable equaling a constant. And notice, that's what we have here. Variable equaling a constant. Variable equaling a constant. So just one solution. All right. Well, let's jump over here to number 14, since it has both possibilities, either all real numbers, meaning infinitely many solutions, or no solution. Let's work through it and see what happens. Negative 1 doesn't change, so let's just write it down. So negative 1 plus 7 times a, that's 7a. 7, notice that is a negative 4, so plus a negative 28. And I'm going to write it that way just to make sure I know that it is a negative value and not a just a subtraction, and I forget that it's negative. Equals negative 37 plus 7a. And you should stop right there and notice something. 7a, 7a. Same coefficient, meaning it's going to be one of these scenarios, either no solution or infinitely many. So the question is, how do I know which it'll be? Well, let's look. If I take negative 1 and add it to a negative 28, I'll have 7a plus negative 29. That'll be my constant here. Equals, and I'm going to rewrite this side so that way my term with the variable appears first. 7a plus, in parentheses, we need to put parentheses in there, negative 37. So let's stop for a minute. We've got a 7 and a 7, so coefficients are the same. I've got a constant of negative 29, but over here I've got a constant of negative 30. Well, which of these originals does it look most like? Well, it would seem it's a no solution scenario. Same coefficients, but different constants. So this is a no solution scenario. So I should be able to stop right there in my work and say, I'm done. Okay, nothing else needs to happen. If you don't believe me, well, let's take it a step further. I want to get the variables together. And notice, this is a 7a, so to get rid of it, and let's say we'll move it to the right-hand side, I'm going to subtract 7a from both sides. Watch what happens. We get negative 29. Notice 7 minus 7 zeroes out. Over here, 7 minus 7 zeroes out, and I'm left with negative 37. Well, notice, those don't equal. All right, so I didn't really have to do this final step. We could have stopped right there and recognized that 7 of something does equal another 7 of something, but I can't take 29 from here and 37 from there and have it equal out. So a no solution scenario. All right, well, let's look at another. Let's look at 18. All right, 18 here has a all real numbers possibility, so let's see what happens. This left-hand side can't simplify, so I'm just going to write it out. Negative 35 minus 5x equals, and if that bothers you, let's change it. Add a line, change a sign, I'll put it in parentheses to know that that is indeed a negative 5x. Over here, negative 5 times x is a negative 5x. Negative 5 times 7 is a negative 35. Okay. I'm going to rewrite all this just to make it a little easier to see. So this term would come first, negative 5x minus 35. Again, subtracting a positive, same as adding that negative. Negative 5x, and I'm going to rewrite this so it's not plus a negative, minus 35. Notice they're exactly the same. Same coefficient, negative 5, same constant, negative 35. I'm sure those 5s look like 5s. Okay? So they're exactly the same, meaning that this is an all real numbers scenario. Now again, if you don't believe me, if you're not sure, there's an easy way to check. I'm going to get rid of the variables. Since it's a negative 5x, I'm going to add 5x to both sides. All right. So these zero out, we're left with negative 35 equals. These zero out, negative 35 is all that's left. And notice, we get a very obviously true statement. Of course, negative 35 equals negative 35. So this is an all real numbers or infinitely many solutions scenario. Right? So that's how it plays out. So in a case like number 20, notice they give us both options. So it should be very easy for you to figure out what's going on.
Charles, can you get us some painter's tape, please, and meet Miss Hunley in the cafeteria, please? Again, painter's tape and meet Miss Hunley in the cafeteria.
Oh, you gotta love those announcements in the middle of a video. So let's go ahead and work through it. We should be able to figure out rather quickly, is it going to be one solution, which could be B or C, or is it going to be no solution, like A, or infinitely many, or all real numbers as in D. So let's do our distribution here. So negative 3, nothing happens with it, plus 6 times n is n. 6 times negative 1 is negative 6 equals, let's read through this here real quick, negative 9 plus 6n. Now notice, we've got some cleaning up to do here. We can simplify. Negative 3 plus negative 6, let's see, 6n plus, and that'll be a negative 9. And I'm going to rewrite this so that way we're in that constant format of having our term with a variable first. So 6n plus negative 9. What do you know? They're exactly the same. Same coefficient, in this case 6, same constant, negative 9, meaning I don't have to go any further. I know that this is an all real numbers scenario. It wasn't a one solution scenario, and it certainly wasn't a no solution scenario. It's all real numbers. And I can stop right there. Notice I did very little work. Again, if you're not sure, if you're one of those people that just puts your head down and just works, well, let's see what happens. I'm going to get rid of the variable next. So subtract 6n on this side, subtract 6n on this side. 0 plus negative 9, well, that's negative 9. And then 0 plus negative 9 is just negative 9. Notice that's obviously true. All real numbers. So again, I hope this video helped you understand the difference between our different solution types, our one solution, no solution, and then infinitely many. Pretty easy to tell, and I like especially these two because you end up not having to do a whole lot of work. You know, just a little bit of cleanup, and it should be very obvious whether you have no solution or infinitely many. The real kicker is when you have one solution and you've got a lot of work to do. So if you're good to go, I'm glad, and if not, come by and see me in the mornings, and I'll be happy to help you out.